Good morning, everybody, and thank you for coming in this early time. Today's agenda, I'd like to make some announcements specifically maybe about your assignment number 1. I want to just remind you guys just about what you should really watch out for. And then some other general announcement quickly, and then we'll move on to the technical part for the section. I already covered all the questions on the Google Doc yesterday. You can definitely refer to recording as usual, except for one question I would like to follow up with a precise code to write. That's something I will talk about. And then yesterday we spoke about how you can do a reversal of a chain of notes. It's a very typical interview problem, actually. LeetCode, cracking the code interview book. You can definitely find the reversal problem. It's still considered an easy problem. I think since you guys are only beginning to learn about singly linked list, I think it might be nice to do it together. I already spoke about the solution yesterday, only just to program in Java in Eclipse. But I would like to trace it together with you guys just today so that you can get even more familiar about the process of the tracing algorithm, especially when your algorithm you thought it would work, but it's actually failing some test. It's definitely not working, right? So that's something I'd like to talk about. And then that'll be it. I don't really have like a very challenging extra problem for you today, but I promise for this section I will bring reasonably more challenging problem for just this section next Thursday. So you really wake up early for something. Okay, that's something I'll get prepared and they'll get in touch with you. I'll try to send the problem to you maybe a little bit earlier so you can get prepared. We'll go over the rationale for the design. We'll go over the solution. We'll go over the tracing just for this section. All right. Alrighty, so let's now talk about the stuff. Okay, I would like to start with the announcement for everybody. Okay, sorry, over here. Good. Okay, the announcement. Your lecture number 4 has been released in time, as usual yesterday, lecture week number 4. I would like to just draw your attention to 2 highlights. Of course, you're going to study the complete details. It will definitely be relevant to your written test number 1, which I'll speak about maybe briefly because I'm going to look at the course calendar in just a moment. So we're going to finish off the discussion about singly linked list, especially I want you to pay attention to three things. Okay, number 1 and number 2. Pay attention to there is a method called add last, adding a last node into the list, and also remove last, which is of course the kind of the opposite direction, right? The opposite effects. You want to remove something, but the last node in the list. These 2 nodes seem to be having something to do with the end of the list. So you might think intuitively the running time of these 2 operations will be very similar. Well, at least asymptotically they would be the same, but it turns out they are very different. One of them is actually more efficient than the other asymptotically. So that's something I would like you to pay attention to as to why. Okay, I'll leave the discussion, the detailed discussion, to the actual recordings. I think I made it very clear and thorough in the actual lecture. So you definitely want to follow that. And also number 3, which I think that's even more important, I cover about 6 to 7 different operations about singly linked lists in the past 2 weeks, well, including this week. I think that there are many more problems that we haven't solved. I'll definitely try to solve some throughout the semester, maybe some more linked list problems, so you can definitely get motivated and get some feeling. And but there's another thing I want you to do as well, which will be also to do with the basics. There are quite a good number of exercises which I assign in the lecture, both week number 4 and week number 3. I want you to also try them out, not only to extend the source code that I gave to you, but also to write some JUnit test cases. I think it's very, very good practice to you, right? At this point, you are basically finishing off your second year, and once you move on to the 3rd year, I think your programming proficiency will even be assumed by your future instructor. So I think that it'll definitely be a good thing that you really practice, not just writing code and assume that it's actually correct. You definitely want to write test cases, okay? And we also review about how to use generics in Java, right? Especially what would be the difference when you say node of string versus if you say node of integer. Right, so this is part of the discussion which I'll review. And of course, I already suggested about 2 weeks ago some background study about generics in Java. The basics is something we have to assume you already learned from the earlier Advanced OOP course 2030. And you should definitely study the background because it will be covered also in the coming written test as well. Yeah, I'll talk about it in just a moment. Alrighty, we got some also discussion yesterday in yesterday's Q&A about generics. You can also refer to that part of this the discussion. You can see the timestamp from the recording. All right, so that's about lecture number 4. You definitely want to study that in time and ask me question next week, so you will get ready for your written test 1. And for your assignment number 1, right? It was released on Monday, right? It was released, and you got about slightly more than 2 weeks to do that. And for the actual deadline and also the time by which you have to make submission, please check your PDF instruction, right? But I'll go to the PDF just to go over some parts together with you. And I want to draw your attention to, in case you are not aware of, we do have some scheduled TA hours, right? Starting from this week already. Okay, I'll show it to you in a moment, right? So these are optional. These are just resources made available to you. So if you don't use them, they're just wasted. So I would say if you want to speak to, in addition to speaking to me, if you want to find more chances of clarification or extra dialogue, you can definitely speak to the TA. I think they're good TA. They'll be very helpful, right? Either for assignments or maybe for course material, right? Either way. Alrighty. Do you guys have any administrative questions for me at the moment? Anyone? All right. Hearing none, seeing none. I want to do 2 more things before Masato, please.
Good morning, Professor.
Good morning.
Sorry, when was assignment 1 going to be due?
Let's now check it together. Yes, that's something I would like to talk about. No problem.
Thank you.
Yeah. Okay. So so I'd like to talk about 2 things right now. Let me first of all talk about assignment number 1. Just highlight some parts together with you. Number 1 and number 2. I want to just go over the semester calendar to tell you what to expect. Okay. Let's look at the instruction for assignment number 1. If you log into eClass, and you will see the assignment 1 instruction over here, right? If you click on that, okay, and in response to Masato's question, it will be due 2 p.m. EST, Eastern Time, Tuesday, February 15th. So it's actually right after your written test number 1. So I think you definitely want to study hard, of course, for your written test 1. So it might be your best interest. Maybe try to complete your assignment and submit it maybe by Monday noon, right? So you can get it out of the way, right? But anyway, so that's the deadline, okay? I'm going to remind everybody maybe by a couple of announcements before the deadline. So make sure that's the deadline. It's going to be strict. Okay, that's one thing here. And then you can definitely read other parts, but I want to draw your attention to 2 parts very quickly. Number 1, it's about the requirements for this programming assignment. The assignment is purely programming. So that means, number 1, compilation is very important, especially you guys are already finishing off the 2nd year. I think that it will be a reasonable minimum standard. Whatever you submit must compile together with the given starter test case, the starter tests, JUnit class. So that one there, you shouldn't really make any alternations to the starter test. You're welcome to test for some additional test cases, but just add some additional JUnit class, maybe in the tests package. Okay, that's what you can do. But don't really modify the starter test.java itself. Okay, and you want to make sure you don't really have any compilation error. Otherwise, there will be a 20% penalty. I don't think you should really receive this, right? It is very easy to avoid. If you got trouble getting things to compile, really, you can come to me. I can help you a bit. But of course, you want to also try to fix the compilation error yourself. Otherwise, you'll get trouble when you do the programming test. And the second thing over here, let me try to explain that a little bit. Well, actually, it's already self-explanatory. But for this assignment here, we want to focus purely on singly linked node specifically, right? So that means we want you to really design and implement your algorithm purely in terms of singly linked node without the help of other data structure. That's the goal, right? So that's why in this assignment here, you are forbidden, number 1, to use primitive array. You cannot use it. All right, number 1. Number 2, you cannot use any Java library classes. For example, like an array list, or maybe substring, erase the copy of, and etc. You can read the instruction for detail. So these two things are not allowed for this assignment, right? You don't really try, just be careful. Just don't ever think about using it. I really want you to focus on designing algorithms and implementing them purely on singly linked node. I think you'll learn quite a bit in this. Something that toString should be okay, right? Yes, something that toString is fine. However, I would say this is a slightly easy way to really get a string. I know which method you might be talking about, for example. I'll show it to you. You can use that toString, that's fine, but I don't think it's really necessary. Okay, let me show to everybody here. Okay, let's say if I have integer I is equal to, let's say 68, right? And then over here I have string over here. Let's say S. How can I convert I into a string? There is a very easy way. I'm not sure if you guys are actually aware of that. Maybe some of you are, if you visited my office hour earlier. You can simply say I. If you simply say I over here, there's going to be a compilation error because integer is not compatible with string. However, if you do the following trick, I concatenated with empty string, this will work. Awesome, Masato, very good. Yeah, if you do it this way, in that case, what Java will do is they're going to do some implicit, I believe maybe like a promotion to say, since you're doing plus, and in that case, the string concatenation will actually get a priority to be done. So that's why it's going to be treated as like an entire string. So we're effectively converting from 68 into 68 like this, right? So that would be one way for you to convert the integer to string. That might be what you're thinking of doing. But to string is okay. That one's fine. But you got to be careful, right? Because sometimes you may have used some library method that turns out not to be okay, which is not good, right? Alrighty, that's about the requirements. Good, no problem. Please make sure you read them through. And let's see, in terms of the background study, so for these two, since I said it's optional, so you have to make the judgment call. If you believe that you're already confident with the background, you don't need to study any of them. You don't need to waste your time. On the other hand, if you believe that your background on these two subjects are not as solid as you might hope, in that case, you may want to study them, right? That's why I say it's optional. And for the required studies, of course, the lecture material for week number 4, week number 3. And if you want to see some very quick reminders about how to use generic classes, how to instantiate generic classes, you can look at this little write-up. I think that's quite self-contained, so you can definitely refer to it. That actually summarize many useful points for you for assignment number 1. Okay. Final thing I would like to mention, only a very small number of you guys, maybe actually even reach out to you personally. Some of you did not really have an EECS account. Actually, that will be important for you to really register one, activate one. Otherwise, when you submit your assignment, you might run into trouble. All right. For those of you who, maybe not the ones attending the live session, but for those of you who are watching the recording, and I'm gonna remind you by the announcement, if you haven't got an EECS account, you should really activate one. Otherwise, you may get trouble in getting your things graded, getting your assignment graded. All right. Okay, so that's about number 1, about the assignments number 1. I would like to talk about quickly the semester calendar, just to see where we are. Okay, go to the 2011 lecture site and go to semester calendar over here. Already we are now over here, February 3rd over here, and time really flies. We are finishing off the first 1/3 of the course, right? Very soon we'll reach to the reading week. After that, things will move even faster, right? Anyway, so we still got many exciting items ready for you to learn. We'll see. Okay, your written test number 1 is actually going to happen on week number 6 over here. I will send you some preparation guide just to specify the coverage and also the formats for the test. I'll confirm that in writing, so you can expect to receive an announcement from me tomorrow. All right, so just tomorrow. So you got at least 1 week. More than 1 week to really get prepared and also plan your studies steadily. But I don't think the coverage for the material will be surprising, right? I just want to confirm that. right? So you can expect an announcement from me tomorrow about written test number 1. Okay. All right, that's about everything administrative I would like to talk about. Do you guys got any further questions? Please, you can ask me now. Otherwise, I'm gonna dive into the technical contents. Anybody? Masato again.
Hello, Professor. Hi
Hi.
again. We are all going to return to campus on February 14th, right? So
Yeah.
would written test 1 be in person?
Okay, good question. There's something I'll definitely confirm tomorrow, but I think most likely for your written test number 1 is going to be online. Most likely.
Okay.
Yeah, but so basically you will have to. That's something I will try to maybe specify more in the guide. I understand the only difficulty, the logistics difficulty would be maybe some of your other courses might require you to be in person, maybe to attend a live lecture, which is possible. In which case, you may have to run between in-person lecture and the online exam, the online test. So I think number one, making remember what we said in the syllabus. You can either take the test during the Monday lecture time, which will be from 4 p.m. to 5:30. Or you can take the written test during your enrolls section Z, which will be from 8:30 to 10 a.m. on Tuesday. Either way is okay. So now the only challenge would be, let's say I did receive an email from one of your fellow students saying that they actually has another lecture either before or after. So my suggestion would be, which I'm going to mention in the guide, there are several options for you. Number one, you can maybe book some study room, maybe in the Scott Library or Stacy Science Library. I believe they open quite early, and they do have assistant over there. So once I confirm the format for the written test 1, you should really look into it. So that would be your responsibility to make sure you have a place for you to actually concentrate and write a test. That'll be number one. Or number two, I will confirm with our director of computing, hopefully today or tomorrow, just to see when the prison lab, on the ground floor of the Lassonde building. I think there are many workstations over there. I want to confirm like at what time they will open. Would they? I'm not sure if they will open as early as 8 a.m. I'll ask them. Right? Maybe it's the case. I kind of it's been 2 years since I actually look into the hours of operation for prison lab. But I'll confirm with them, so I can also confirm that. And or you can just find any spot on campus that actually got maybe Wi-Fi. Just make sure they got some stable Wi-Fi somewhere, and then can write your test there. Or if you didn't really have to commute around that time, you're at home, then that's definitely will work for you, right? So I think that will be at least for written test 1. But as I mentioned before, for other remaining tests, i.e. written test number 3, written test 2 and 3, and also your programming test 1 and 2, for them, I will just confirm at least 1 week in advance. In principle, or in the first instance, they will be online. If I need to call you guys back for in-person assessment, I will let you know at least 1 week beforehand. So Masato, is that clear to you? I hope.
Yep, I got that. Thank you very much.
No problem. I'll also confirm this in writing, so you'll be definitely clear. Yeah, good. All right, guys. Any more questions about this? Yeah. Alrighty. Okay, let's now talk about. I got only 2 things to talk about, right? I only checked last night. There were no new questions on the Google Doc. So, but if you guys got any relevant questions to the lectures, you can feel free to ask me, interrupt, or if you want, right? Let me talk about this one first, okay? This one was inspired by one of the Google Doc questions from one of your fellow students. Remember when I spoke about the count the number of nodes problem? That was the very first problem we solved on the syncly linked list. It was on week number 3 lecture. I asked you guys to pause the video and think about how you can do it. And one of your fellow students thought about some solution that's very different from mine, which I thought would be nice to share. So they didn't really specify exactly how they coded up. But I think this would be what they really had in mind. So we can share, we can talk about it, right? But I'll kind of transform that into more like a problem for us to solve. Okay, I can definitely give you guys an opportunity to think about how you might solve it. Let's take a look over here. So here's a problem. let's say we got our simply linked list class. Let's say we don't have that size attributes, right? Let's say we don't have it. We only got head. And also we got the node class, right? It's obvious we got element, we got next, just the same class as you were given for your assignment number 1, right? We got these 2 classes, okay? And what we want to do now is to implement this getSize method over here, right? And what you're assigned to try is to see what to put inside, right? Of course. But here's my problem. You are allowed to modify either this class or this class if necessary, either one of them. But the idea would be we want to implement the size method, or to count the number of nodes, without an explicit loop. Is it possible? Okay, you can think about it. It's not a difficult problem. I think maybe it's intuitive. That's why your fellow student would actually think that way, which is good. I will pause for maybe 1 minute or so. At least you understand what the problem is. You can think about how you may solve this problem here, right? Okay, let me just make one more note over here. You can modify. Apparently, you can modify simply linked list class. Of course, you can modify the node class if you wish. You don't have to, but if you want, you can do it. You can take that as a hint. All right, I'll pause for 1 minute until maybe 8:57-ish, and then we can talk about how to implement it. So while you're thinking, what I would do is I'll just write a very small piece of code. Once we got a solution, we can test it, right? I'll write it down on the same paper. Okay. Okay, let's wait for 1 more minute. Okay, I'll be done with setting up the test. Alrighty. All right, so that's the test that we're gonna check together. Very simple one. All right, any thought? Can we use recursion? Yeah, sure. If you want to use, yeah. I actually, you know what? I would say typically, if the computation is going to involve multiple things to be computed, either you can use loop if you want to make it explicit. If you cannot use loop, then most likely you want to use recursion. But I would say for this one here, it's interesting. It's not exactly like a recursion in some way. It's yeah, not the typical recursion we will do. Okay. So John, so before we hear your solution, just in the interest of time, why don't I write down what I have in mind? You can tell me if that's what you're thinking. Okay. So I would suggest what we can do is we can modify the node class over here. Okay, we can modify the node class over here, and then in the node class, we're just going to introduce one accessor method over here, which is also called getSize. Okay, integer and getSize. No input parameter. Of course, it should be public. I'm just omitting it. Right? All right, over here, I'm gonna write the following. I would say if the next reference, well, I can make it even more explicit for you. I can say if the current node the next is equal to null, that would mean only this node itself, but there's no other node following it. In that case, we should return 1. Right, just itself. Okay, make more space. Otherwise, we're going to return over here itself plus okay, just bear with the symbols over here, right? So that's what I'm thinking about. Let me just actually box this, and then of course there's one more thing we have to do, because our goal, remember, originally was to define the getSize method in the simply linked list class. So what should we do now? Given that we have this method available at the node level, right? Over here, the dot 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 over here can be just a single line over here. Guys, what should that be? What should that single line be? Anybody? You can type on the chat. Single line, not even conditional. Anyone want to try? What should that line be to complete the getSize? Head.getSize. Awesome, right? Of course, you missed the return, but that's okay. Return. Yeah. Head dot get size. There we go. Right? Well, as you can see in this line over here, in this line over here, in this block over here, there is no explicit loop. So we are really satisfying the problem description, right? But why would this work? In some way, it's what if, oh, sure, we might need conditional then. Yeah, awesome. Good thought. And I can show you guys some syntax over here. Have you guys seen this syntax before, by the way? I can, maybe I showed that maybe earlier in the first year in my class. Okay, let me show it to you. So have you seen this syntax before? It's called conditional statements. Like that. So this is a syntax over here in Java. Let me put on the syntax first, and I'll give you one example. All right, so this will be some Boolean condition, and this will be expression of type t. T can be anything, can be integer, can be string, can be anything, okay? And this expression over here should be the same type. It must be, otherwise you get compilation error. Type t as well. And the entire expression over here is going to be type t. Right, so that's so-called conditional statements in Java. Normally, I wouldn't really cover that in the lecture, but I think it's something that people also use a lot, especially if you don't want to really have the if else if. But feel free to use if and else if. There's nothing wrong. Okay, let me give you one example here. Let's say I expect to really return some integer, right? So I can say return. Whenever I'm expecting some expression, I can use this. I can say return. For example, I'm going to return maybe 23 if x plus y is actually true. Otherwise, I'll return 46. Right? So the way I can do it is I can say I'll check for this condition over here. Is it true? If it is true, return this integer expression. Otherwise, return this integer expression. All right. So for those of you who might be interested in seeing the some more example, you can definitely Google for that. It's called conditional statements, I believe. Conditional statement, which is a nice alternative to if else if sometimes. All right. So what we should do over here is we can say if the head is actually null, then of course the size will just be 0. Let me just do purple. If the head is equal to null, if that's the case, it's going to be 0. Otherwise, I can put it here. It's going to be head dot. We'll talk about the running time in a moment. Without a loop doesn't really mean it's going to be constant, by the way, right? So that's why it's interesting to talk about this. It will be worthwhile talking about this example here, right? Get size. All right, so that's about the entire definition over here. Return something here. Okay, let's now trace it very quickly just to make sure it works, okay? And as I wrote over here, I can make the test case maybe a little bit smaller so I can have some space for me to draw diagram. Okay, let's now try to take a look. The size. Okay, I think it's still visible, so that's fine. All right, so let's now talk about this example here, right? Line number 1, we're simply creating a chain of nodes, right? The first node is going to store A. Its next node is going to be another node storing B. So what we have is N is basically pointing to the beginning of this particular node. Let me draw it in this way, okay? And it stores just A, right? Let me just put A here. And the next node over here is pointing to just another node storing B, right? And that one there is simply pointing to null, right? You definitely would see expression like this a lot in your starter test for assignment number 1, okay? And what about the next line? The next line, we're simply creating some singly linked list, and we're going to set the head to be N, right? So that means the head is basically pointing to the same node over here, right? So that's what we are setting up. And what we want to call right now is list.getSize, and make sure that will return 2, right? Let's now trace it, okay? If you try to call this list.getSize, it's going to go to this particular return statement here, and the head is not equal to null. So that means we're going to go for this path, and it's going to go for head.getSize, and the head itself, right? So now you got to be very careful. You got to know what's going on here. So here, when you say head.getSize over here, you're basically calling the version of getSize in the node class. On the other hand, when you are calling this line over here, the context object is actually list. So this will be the version of the getSize in singly linked list, right? We're calling different versions, right? We got 2 versions of the getSize, but of course, they'll work together. And then let's see what's going to happen here. So when you try to trace this getSize over here, right, over here, so we're going to say if this.getNext is equal to null. So currently, you can think, so the context object is actually the head, right, which is this particular node. So this is the context node that we're talking about. Its next is not equal to null. So that means we're going to go to the else part. And we're going to say 1 plus, right? And then we're going to invoke this getSize again on its next. So that's why it's that's what it will make it work, right? So you can think about at the moments in the stack, right? If you think about the cost stack, what we have over here. Initially, we try to call list.getSized. List.getSize, which in turn will actually call this one.getSize, right? The head.getSize, which is over here. And then it's going to call head.getSize. And when we call head.getSize, it's going to in turn call again this.next.getSize, in which case it will be this particular node that gets size, right? Can I just name this tentatively? Let's say only n2, right? You can think about that one here is going to call n2 dot get size, right? So at one will be pending, suspending just for now, all right? And you can see when we get to n2 over here, in some way it's more like a base case. So when we get to n2, and then you can see here, this dot next, n2 dot get next will be null. So that means it's going to return 1, right? So that means this part over here that's pending is going to be 1. So what's going to happen is this is going to return 1, and then don't forget the 1 plus. So 1 plus the return 1 is going to be return 2, right? And then the 2 is going to be returned back to this particular expression that's pending, right? So that means this is going to return 2. So that'll be the final answer. And of course, I just realized I forgot to say return over here in the code. All right, that's basically how it works. And what's the running time for this? Should it be constant, or should it be linear, or even more expensive? I already saw from Ali. He thought it should be linear, right? Ali, you want to say something? Yeah.
Yeah, hi Jackie. So I want to say I think it's linear because it's gonna do if the number of nodes in your linked list is n, right? It's gonna do n function calls, which is I think we call that a primitive operation in your thing. So regardless, it's gonna do it n times either way. So you're kind of traversing it in a weird way.
Indeed. Yeah, indeed. Absolutely. I definitely agree with Ali. Ali pretty much said the correct thing. Let me just try to elaborate a little bit further. You can think about in this algorithm over here, we always start with the head over here, which will be pointing to the beginning of the node. Every time we want to delegate the get size to the next, we have to invoke the get next over here. So you got to think about how many times do we have to call the get next? Well, it will correspond to how many nodes we actually have in the chain. So that's why it's linear. Yeah, so the answer will be linear. So every time you want to call the get size again, you have to invoke this this dot get next. So this part over here is really bigger of 1. This part here, this part here is definitely bigger of 1. And of course, eventually you want to perform some arithmetic to do the addition. Excuse me, the addition that's also bigger of 1 for sure. So now the idea would be how many times do you really have to call the get next before you can reach the base case where you will simply say return 1. You have to get to the very end of the list where the next will just be null. So you basically, as you said, you're basically traversing the list from the beginning until the end. So effectively, what you're doing here is even without using an explicit loop, but it boils down into you're still traversing the list by using the get next until you reach the null over here. I thought it'll be very interesting to consider. Right, let me say a final remark on this exercise over here. I think it's definitely worth discussing this. I think this turns out to be equally efficient and also equally well in terms of working to get a size. You can feel free to choose whichever one you like if you got the freedom. For example, if I say you cannot really modify this class, in that case, of course, this solution wouldn't work. Right, but if I didn't say anything, in that case, you can either choose to use an explicit loop, or you can choose to use something here, right? I believe later when we talk about the trees data structure, I don't quite forget the detail. I think some of the implementation there, we allow you to so-called augment your class. So in some way, we're augmenting each node with a size to say, starting from this node, how many nodes, including myself, follows this? Basically, that's what we're doing in the get size. But let's see if maybe later on we'll see more example. But this is definitely valid for sure. All right, John, is this what you were thinking initially about recursion?
Yes, but not like this deep. I didn't think of the full solution, but this is like
similar, right?
This is really good. Yeah.
Okay, awesome.
Also, could this be used the same way, but now to get tail, right? Because
indeed,
follow a similar way.
To get the tail, let me see. Yes, I think yes, this can be used the same way as to get a tail. Yes, basically you want to, yeah. So you will say get tail over here. Yeah, so get tail will not only be defined over here, declare over here, but also declare in the node class. Yes, and then you can say get tail. Yeah, that's right. I'm pretty sure you can. Alrighty. Yeah, so if you guys want to try, I think John's very kindly suggests maybe some exercise if you want to do, right? Exercise. You can try get tail method in the node class. All right, so that's something if you want to try, you can feel free. All right, and if you're not too sure about if your solution is correct, feel free to get in touch with me. I can go over that with you. All right. And another thing that we also show to you, you can also feel free to use it in your programming tests or in your assignments if that's applicable, right? Which is about conditional statement. I use that sometimes, not often, but sometimes. Yeah. Any follow up to this question here? Anyone? All right, so hopefully everybody is okay, right? Let me now talk about one more thing. In my agenda, right? And then I'll open the floor to everybody for any further questions. But so this one here is about reverse off, which I programmed yesterday on Eclipse, right? Yesterday, and this is the correct solution. And what I didn't really do yesterday, because I want to reserve maybe the tracing part for this section today. So you guys got something new from yesterday. Okay, so I'm going to trace it together. It's incredibly surprising that reverse turns out to be much easier or much simpler in terms of the coding. The structure is very similar between reverse or just to copy the entire chain in the same order. Between these two algorithms, their structure for the code is very similar. You have to have some while loop, and you got to do some reference setting as the body of the loop for both. However, the lines of code you have to write inside specifically around here is simpler in the case of the reverse because you don't need any conditional. Let me just point out to you what you can also study from yesterday. Okay, if you go to yesterday's recording, I presented a problem over here about reverse, and then I gave you to your fellow student this particular alternative solution over here. You can see this one turned out to be more complicated, and this one here is wrong. This one is not doing the reverse. This one literally just copied the entire chain of nodes without modifying the order. They simply preserve the order. All right, so this solution here, and then I did a little bit like a drawing and tracing to show people why this is not doing the reverse. I think it'll be a valid, also valuable exercise for you to do if you want to, just to make sure. If I give you something, for example, in the test, I can just ask you whether this algorithm will actually satisfy this particular intended goal. If it doesn't, you can say false, right? So this is something you can definitely look into if you want to, right? It's recorded. All right, let me talk about the actual solution over here, right? And this is the one, right? Let's now trace together just to make sure you just get convinced why it will work. Let's do that quickly, right? And then I can answer other questions. So here I got basically two cases over here. So we got, let me just use green. Okay, case number one over here. Let's say the input chain is simply just null. In that case, the output is also going to be null. This makes sense because the reverse of an empty chain will just be empty, right? And this one here, I don't need to draw. I just showed to you. If you think about how this is going to work, the input is simply just null. That means the current node, remember the current notion, right? That we spoke about in the lecture. If the current is simply null, null not equal to null is going to be false. That means we bypass the entire while loop and simply return null, right? That's trivial. Right, so this one pass. Okay, so what we can do is we can now talk about the remaining part, and this part over here simply just creates an input chain of nodes of 3 nodes over here, right? 1, 2, and 3. Right, let's now draw that input here. So the input is going to be, let's say, input, and we got 3 nodes over there. Let me draw that very quickly. And over here, and I can copy this. 1, 2, and 3. So we got Alan, and we got Mark. Being able to draw and also trace linked lists will be a very important technique, because maybe for your assignment number 1 or for your programming test later, you program something on linked list and you believe it's working, but apparently it's not because you failed in some test cases. In that case, it will be very difficult just by looking at your code and figure out exactly what's wrong. So the best way to do it would be to really draw maybe some diagram following the test case to see exactly what's wrong, right? Of course, you can use debugger if you also feel comfortable. You should really consider both whenever you want to debug, right? All right, let's now talk about the output here. And the output is simply going to be the reverse of the input, right? Let's now trace it. So the reverse of over here, and the input, of course, is just going to be the input over here, right? Okay, the input here is the input here. Alrighty, let's now try to trace it. The first one here is going to be reverse. Reverse, eventually we're going to return it. So we initially just set it to be null. Okay, and then we also got the current. Current now just tell us where we are in the input, right? So the current, let me put it here, is here to begin with, right? And the current is not equal to null, indeed. So that we're going to go for the first iteration. And then we're going to have this E here. E is going to be current.getElements. So you can think about the E is really pointing to just Alan, string objects over here, right? And then we got a new node over here, which is going to store E. And then the null, right? So what we can do is we're going to have the node N. So N should be pointing to a new node over here. You know what? I would suggest I actually do it this way. You will see why. Okay. And let me try to put this over here. Okay, that'll be better. Okay. N is pointing to this node, which will store Alan, right? I would just say Alan over here, but conceptually, you should really understand it's really the same string objects. We're not really duplicating the same string objects, okay? Just for simplicity of drawing. Let me put Alan over here. All right, and then the next will be null. Alrighty, and then we're gonna say n.setNext to be reverse. n.setNext to be reverse. You know what? I think, yeah, n.setNext to be reverse. That means the reverse over here, n.setNext, rather than pointing to over here, is actually going to point to the reverse. Okay, and okay, n.setNext is a reverse, and the reverse is going to be assigned to n, right? So the reverse, rather than pointing to over here, is pointing to over here. That's the first iteration. All right. Hopefully, so far so good. All right, and then we're going to say current is going to be assigned to current.getNext. So current is going to be assigned to current.getNext. Current. From the first iteration, you cannot really see if that's really working. You still got to see the second iteration. I think that once we get to the second iteration, we might just be able to stop because we can see it's being set in the proper order. So what we expect to see is, after the second iteration, Mark should really somehow be pointing to Alan. That's what we should expect to see, rather than Alan pointing to Mark, right? Because that would not be the reverse, would it? Okay. Let's now try to do the second iteration. All right, for the second iteration, let's now see. Let me use maybe green. Okay, for the second iteration, the current is pointing to here. That's definitely not null, right? So what about the string E? So the string E will be current.getElements. So you can think about the E is right now pointing to Mark. All right, and then we're going to create just another new node. Okay, so let me put a new node over here. That's a new node. So let me call the N over here. And then it's going to store E, and also the next will be null, right? E will be Mark. So let me put a mark over here, but just understand they are the same string. And then the next will be null. That'll be the new node, right? The next two lines will be very critical over here. Okay, and set next reverse, right? And set next should be pointing to wherever the reverse is pointing to, right? So that means we're going to let and set next to be reverse over here, right? That's the first line. The second line, we're going to say reverse is assigned to n. So that means the reverse, rather than pointing to over here, is pointing to over here. All right, that's what we have done. So far, so good. Okay, and then after that, we're gonna move this current to the next. But you can see so far what we have achieved. Basically, you got the reverse over here, and then it's pointing to Mark, and Mark is pointing to Alan, which is good. All right. So it's definitely trying to reverse the list. If you try to do the third iteration, it's going to put Tom over here and then let it point to Mark. That's what's going to happen. All right. Guys, do you have any question about the tracing over here, right? I don't need to really go for the third iteration, so just to save some time. So I think you already see exactly how things will be reversed just by using the main two lines will be over here. These are the main two lines. Okay. Any questions? Anybody? Okay, everybody's comfortable with this about reverse? Okay, it's not a difficult one, right? But I think it would be worth understanding what might be a valid solution and what might be an invalid solution, for sure. All right. Now I can open the floor to any question you might have related to the course material. You can ask me about assignments. You can ask me about lectures, anything. If you feel more comfortable speaking to me in person, feel free. I got office hour this afternoon. Okay. Let me see. Masato.
Hello again, Professor. I just wanted to check on something. In a linked list, like two nodes should not point to the same node as their next, right?
Ah, okay. You're talking about something like this. Let me draw that. So for example, you got n over here. Let's say n1. And this will be this is the second. Actually, is that if you mean the two nodes pointing to the same next node, right?
Yes. So if we say n1 is pointing to n2, for example,
let's say
and
okay.
we make a different node, a third node, not in the chain, and let's call that n3.
Okay.
And then we say
Maybe
the
like
next of n3. Oh yeah, like that. Yeah.
Like that. Okay. This one here, it's okay, it's interesting. I would say this one here, it's not really something we'll be so concerned about. I think depending on how the test question might be set up, right? I can tell you that this one here definitely is not good because every chain should be somehow in isolation by itself, so it's not really interfered. But in this case, this particular node can either be referred to the next of maybe another chain over here, or it can be referred to the next of this current chain over here. So you got some reference aliasing. This is not so good. So I think for your assignment number 1, I think somehow this would not be allowed because we want to make sure the two chains of nodes are completely separate. So I think that's something you would like to avoid. Yeah, for sure.
Yeah. So the reason why I was asking this is because with our current piece of code where like our current example code that we're using in class, it sort of allows you to do this because the person who is programming can say what the next node is, right? So
Yes,
it's
indeed.
not restricted to 2. It could be,
I see what you
you
mean.
can have hundreds of nodes that all point to
Absolutely.
the same thing. And
Yeah. I think,
So-
yeah, it's a very good thought, Masato. So I think here, so in response to this, you got two possible things you can do. Number one, you will need to, number one, you will have to somehow extend the set next, possibly the set next method, or maybe constructor. I'm not too sure if that's even possible, but conceptually, you may have to go back to your node class. Currently, it's pretty simple. You have to extend, these two methods over here to check and catch such scenario. But I can tell you that it may not be always possible, because you can see, let's say I'm currently creating this particular node, and then I set its next to be this particular node. But how do I know in the context that this node is currently being pointed to by another node? Because remember, in the singly linked node, we only got a next node. So it's not possible even for me to check, right? Unless I have some global, like a program, to really manage that. So I would say option number one may not necessarily work always. Okay. Of course, another way to do it would be, let's say currently I'm trying to do this node over here, but I'm trying to maybe point it to this node over here. That's also not forbidden by the simple mechanism we have in the node class. So this one should also be forbidden as well. Okay. So another thing to do is, which we can maybe do some example maybe later. Implements some method to detect such scenario. For example, there are two things we're talking about here. One is about aliasing, right? You can see they're pointing to basically the same node, right? One is about aliasing. Of course, in order for this method to work, you want to make sure you pass all the necessary chains to the method as input. You can definitely check the no aliasing helper method in the JUnit test class in the starter. That's basically doing this kind of thing. That's one. Or it is something that that's something we can also do maybe later. Is, let's say, given a chain of nodes over here, you want to check to see whether this is so-called cycle, whether it's circular, meaning that if somehow a node's next is pointing back to another node that's its predecessor in some way, because you can see this node is conceptually is occurring before this node. At the same time, this one also occurs before this node at the same time, so that's why it's circular. So that's also something we can write a method to check. So I think number two might be what you're talking about. So if you're really worried about if we have scenario like this, which we don't want, in that case, you may just want to implement some method and call that to check whenever necessary. We wouldn't really want to go for option number one to really get to really somehow pollute our node class to be too complicated. But in some way, it's not really feasible to do so, to check.
Okay.
Yeah, I hope that makes sense to you.
Yes. I understand these two solutions, and and I guess this is just another way of it's an implementation in a different way. I was thinking more like not allow the user to create nodes themselves, and if they want to create a node, they have to create it through a linked list, like through the linked list class.
Yeah.
That way
I see what you mean. It's a very
that
good
way
thought.
it's always,
Indeed. Yes. In that way, so if you only allow the user to, so basically, if in that case, maybe you just want to forbid about the set head method that we spoke about earlier, right? The set head. So you don't simply allow somebody to maybe create some very crazy chain of nodes and then set the head to be that particular chain. Maybe you don't want to allow this particular method. All you allow the user is to have a disciplined way to really add in to the list. In that case, you can just say add first. But I think even that is not safe, because the at first over here unless you do some exception handling, because actually at first is actually okay because you're only passing this particular string element. That's fine. But if your mutator actually takes a node from somewhere else, in that case you cannot guarantee that particular node doesn't really have any aliasing with the current chain, with the current list. Yeah, there are many things you got to think about, of course.
Yes. Okay. Yeah. Okay, thank you very much.
No problem. But I think a very, very valid concern about the bottom line. At the moment, this class over here is very simple, very general. Being general means that many people can do many different things with it. So for now, we just assume you will use it in a disciplined way. But what exactly will be forbidden, we'll always tell you explicitly. For example, you should not, given the input chain, when you want to return another output chain, you should not have any aliasing. That's something we explicitly say and will enforce. But I would say once you go beyond this course, you will have to be careful. Sometimes it may not be so clear what might be forbidden, what might be allowed. So you just got to make some assumption. Okay, good. Alrighty. All right, guys. Any more questions? If no, we can finish the day earlier, so you can maybe go ahead to do other things if you want. Okay, John, go ahead.
Sorry, just a quick question. So when we looked at reversing chains, we looked at it in terms of like the nodes themselves. If we looked at it like in terms of just reversing like a linked list, we could take advantage of the insert first, right? So we can create like one node and that becomes like our head, but then we can just keep inserting things first and that just reverses.
It's possible. Indeed. Yeah, so what John just said was the reverse of method that we gave as a problem. The input you're given is simply just a node. But if the input you're given is actually a singly linked list, and then maybe you're allowed to use some method from there. Well, the easiest way, John, as John said, would be just create another singly linked list, and then you can simply keep adding the first into the empty list. In that case, it will definitely just be reversed. Essentially, you're using like a stack solution. But I will talk about stack later. But John, that's fine if you're allowed to do so.
Yeah, perfect.
But it seems to me so far for all the interview problems I have seen in LeetCode, usually if they give you some link like a linked list related problem, usually the input will just be a single link node, assuming that the link node actually got a chain of nodes following it. You wouldn't be given just the linked list class. So I think the intention is they also want you to build everything from scratch. But they want to see how you can do that rather than giving you the linked list and then give you so many methods that you can use. I think that's the intention. So yeah, similar to what our intention for assignment number 1 as well. We don't want you to use any auxiliary data structure to help you. In that case, you'll be forced to build everything from scratch, which is good. Yeah. Alrighty. All right, guys, any more questions? And Daniel.
Yeah, I had a question about reversing the linked list.
Sure.
I was just wondering because like when we say new node, I was wondering what happens to the old node and like the old chain of nodes.
Oh,
like,
in this
does it get deleted?
No, it doesn't get deleted. In this case specifically, what we're doing is we're creating a separate chain of nodes as the output. As you can see, every time we say new node over here, you can see we're simply creating, for example, this new node over here, which has nothing to do with the earlier one, right? So it's just a new node. And every time we're creating a new node over here, you can see it also has nothing to do with the original chain. And we're simply setting the reference over here, right? So this nothing happened to the original chain, which might be what you are required to do in many scenarios, because whenever you got an input over here, as you say, I really want to keep the input untouched. I just want to return some brand new output, which makes sense. You don't want to have any interference between the two. On the other hand, if the problem was phrased in this way, let me put it, you can try that if you want to. So let's say this specifically. It could be that public void reverse off, and then we're giving just a node. Okay, let's say this is the method itself to be done. Okay, so let's say this is what I want you to do, and what you expected to do in there will be, you don't really return something because it's simply void. After this method is executed, you want the chain itself to be reorganized in a way. So input is not going. Let me just show you the input and output over here. So let me just draw that a little bit more carefully. Let me just use a separate page. Okay, so it's clear to you. Okay, that's something you definitely can try. So this will be like a variance of the problem. Okay. Okay, let me just make it cleaner. Okay. Let me just move this away, and then I will talk about how this method should work. Okay, good. Let's say this is the input, and then the method I want you to implement is this method over here. Okay, and let's say we have the following call. Let's say I say reverse of, and then I simply pass the input. And this method call over here doesn't return anything because it's void. So what do we expect to see? So after this particular call, the input is actually going to basically, by the way, you cannot simply just say inside your method over here, you just say input is reassigned to something else, right? This is not allowed. Well, it's allowed, but it's not going to do it because remember, call by value. Input that you see in the method call is only a copy of the original input's address. So if you simply reassign that to something, you're not really modifying this link over here, right? That's call by value we learned in 2030. So what this method will expect you to do is to do the so-called in-place. Remember, we talk about in-place sorting. When we talk about selection sort, insertion sort, similar idea. We want to do the in-place reversal. Okay, so what that would do is somehow your okay, so let me just do some reorganization over here. Okay, so somehow you're actually going to move them around over here. So rather than Alan, Mark, and Tom, it's actually going to be Tom, Mark, and Alan. That's what's going to happen. Tom, Mark, and Alan. Right? So that's basically what this will do. You can try to see if you can make it work. This one here. So Daniel, do you kind of follow me?
Yeah, it makes sense.
Yeah, okay. Anyway, you can think about this, but this will be more challenging, of course. Yeah.
Yep. Thank you.
Awesome. Good. All right. Anyone else who has a question? Might need a stack for in-place reversal, maybe, but I'll leave that for you guys to maybe think about, and then we can discuss that maybe later in the Q&A. This one might be more tricky to be done than if you just return the reversal. Yeah, for sure. Yeah, you can think about this if that's possible. So exercise over here. Alrighty. All right, any more questions? Alrighty. Yeah, if no, then I'll cut it a day right now, but you can expect to receive an e-class announcement from me tomorrow, just about the coverage and also policy about the test. I'll try to make some example questions available to you guys to practice, but it's not gonna happen until maybe early next week, right? I'll confirm that, right? All right. Meanwhile, any question you might have, drop me an email or just visit my office hour. So today I'm going to extend my office hour since I missed Tuesday. I'm going to confirm the exact time. All right. All right, guys, take care. And then I will see you later. Have a wonderful day.